Hi everyone, Miss Moxley here. So I've got a recording for you for this morning. Just wanted to make sure you could hear me. Sorry, let me check my mic and make sure that all is well. You have, of course, your recording this morning, and then you have your projectile lesson and quiz. Then you need to complete velocity lesson and quiz. Now, Wednesday, we will not have a live session. However, I want this to be a makeup day for you guys. So I want you to look at your grades, go to your grade book, and see where you have temporary zeros. If you have temporary zeros, I want you to go back and make sure that you get those items in. So regardless of whether it's an assignment or a quiz or a test, make sure you go back and get those items in. Now, I do want to point out, as far as point consistency and weights, your tests are going to affect your grade more so than any other item. So if you have a 0 for a test, that should be your first priority in terms of going back and getting that completed. So I wanted to quickly go over Newton's first law of motion with you guys this morning, as well as friction. So the objective: explain Newton's first law of motion, and your keywords: Newton's first law of motion, law of inertia, and inertia. Okay, so when we're talking about Newton's first law of motion, all right, what we're talking about is, let me adjust my screen. Oops. Sorry, guys. I was trying to let you look at the lesson, and I matched the wrong one. I apologize. All right, let me adjust my screen now that we've got this. So with Newton's first law of motion, it is also the law of inertia, and it states that an object at rest will stay at rest. You all should be somewhat familiar with this concept, but you need to understand that an object at rest will not move unless it is acted upon by another force. So make sure you have this memorized. An object at rest will remain at rest, and an object in motion will remain in motion. So again, in terms of your vocabulary, if you see your bold terms in the text here, make sure that you're writing that down in your notes and giving a definition and or some sorts of an example. All right, so when we're talking about the rate of motion, we're talking about inertia. So that's a vocabulary term. Again, it's bolded, and you want to make sure that you have that term jotted down in your notes. So when we're talking about examples in terms of our notes, we need to give an example for Newton's first law of motion. And a good example of Newton's first law of motion is a rocket ship, okay? A rocket ship will not move unless a force acts upon it, and it would continue in motion if it did not have gravity acting upon it to slow it down. Okay, let's go on to our next page here. You had a video in this lesson that you should have watched and made sure that you jotted some notes down. Again, with your question and answers, make sure that you're jotting those down in your notes as well. Here you had an assignment, a small assignment that I wanted you to make sure that you did for your notes. So it says list 5 objects at rest, or find 5 objects at rest. It could be 5 objects off the top of your head, so just something that you thought of, or 5 objects that you see there in the classroom. So make sure you have that in your notes. All right, we've already stated that an object in motion will continue in motion unless a force acts upon it. Again, here on Earth, gravity acts upon all of the objects here on Earth, so no item is going to continue to be in motion. We also have friction, and we're going to talk more about friction. We've already done the frictionless world assignment. With friction, friction also is a force that acts against motion, okay, and it will cause objects to slow down. All right, Newton's first law of motion, again, is the same as law of inertia. An object at rest will stay at rest, and an object in motion will stay in motion. Make sure that you have these question and answers jotted down, and we've already stated what inertia is, but you also need to know what equilibrium is. Okay, and equilibrium is when all forces acting on an object remain the same. So equilibrium means there's a balance. And here, when we're talking about forces, we're talking about an equal amount of forces that do not change. So there's no addition or subtraction in terms of forces. Oops. All right, now with friction, let me pull up friction and let's quickly talk about friction. We've talked about friction in terms of the frictionless world. In that assignment, you guys were to write a short story, a small essay in terms of discussing what would happen in a world without friction. And it wanted you to discuss if you were on a bicycle and there was not friction, what would happen? And of course, we all know that if we didn't have friction, first off, we would have trouble getting started, okay? Because we wouldn't have anything to push against if there wasn't friction. And there's friction between our feet and the pedals when we're pushing the pedals. And then there's friction between the tire and the road or the ground, whatever it may be. There's friction between the tire and the ground in terms of actually pushing us and propelling us forward. Now, once we get started, if there was some sort of a push, once we got started on our bicycle in this frictionless world, we would have trouble stopping, okay? So we would have to have something come in and stop us in terms of this frictionless world. We would have to run into something. We would have to collide with something. We would have to fall off the bicycle, something of that nature in terms of stopping in a frictionless world, or else we would continue just to go on and on and on. So for the friction lesson, your objectives were to explain friction, and your keywords or some of your vocabulary words were friction, static friction, kinetic friction, and sliding friction. So first off, what is friction? Friction is the force that acts on an object and opposes its motion. Now, there are different types of friction. We've talked about thermal energy in the past when we're rubbing our hands together. We're causing friction when we're rubbing our hands together, and we're causing thermal energy. So that's one example of thermal energy and what it is. We can reduce friction by applying some sorts of a lubrication. So you guys can think of oil in a motor or greasing your brakes. Even spraying cooking spray in a pan, it reduces friction between the object that you're going to cook in the pan or your brakes or the components in an engine in terms of engine oil. So we can reduce friction by adding lubrication. Now, we can increase friction by taking lubrication away as well. So that same concept applies. If we take lubrication away, we will increase friction. All right. Now, static friction, with static friction, it holds an object in place and gives traction. So this is the most common type of friction that we are familiar with, is static friction. It's what we use in terms of walking around and moving here on Earth. So be sure when you're going through this lesson that you have kinetic friction and sliding friction. And then of course, make sure you complete your items for today, Wednesday. Look for those temporary zeros. All right, guys, if you have any questions, of course, don't hesitate to reach out. I hope you have a great rest of your day, and I will be speaking with you guys after Thanksgiving.